Hello students, so here we are with the lecture 4 of alcohol, phenol and ether. Chemical properties of alcohols. Lab test. So in the lab, if you have got alcohol, how would you test and find out? So we can do the litmus test. Take alcohol solution and put few drops on the litmus paper, blue litmus paper and the red litmus paper. So it was seen that there is no effect on the litmus paper. That means alcohols are neutral. Then reaction with bases. Alcohols show no acidic character because they do not react with aqueous sodium bicarbonate or aqueous NaOH. But very weak acidic character is depicted by alcohols. So if you take in the test tube alcohol and add sodium metal to it, then what happens? Hydrogen gas is evolved and sodium alkoxide is formed. So basically the this effervescence takes place and the hydrogen gas is liberated. So with this liberation of hydrogen gas, you come to know that uh, it is acidic in nature, very slightly acidic in nature. If it had been strongly acidic in nature, then it would have given the reaction with sodium bicarbonate and aqueous NaOH. But here they did not react with these two. But of course, when you put sodium metal in it, effervescence takes place and the gas is released. Hydrogen gas is released. So this shows the acidic nature of the alcohols. Then reaction due to the breaking of OH bond. So there are actually the reactions are of two types. One is by breaking of the O and H bond and another is by breaking of ROH bond. So if it is H bond is getting broken, then if OH bond is getting broken, then H gets replaced. So when ionization of alcohol is represented by the following equilibrium. When you react alcohol with water, then what happens? Hydrogen ions are given out and alkoxide ion is formed along with the hydrogen ion. This hydrogen ion combines with water to form hydronium ion. So electron donating inductive effect of alkyl group destabilizes the alkoxide ion. As a result, it does not ionize much in water and therefore it behaves like a neutral compound in aqueous medium. Clear? So here you see when alcohol reacts with water, it is giving out H plus ions and forming alkoxide ion, and H plus ions combine with H3O plus H2O to give you H3O plus. Clear? So this is actually the Laurie-Bronsted theory of the proton donation and proton acceptance. So when alcohol is giving out its proton, it acts as an acid and it forms conjugate base, that is alkoxide ion. And here H2O accepts this proton, so it is base and it forms conjugate acid. So this electron donating effect of the alkyl group destabilizes the alkoxide ion and hence as a result the alcohol does not ionize much in water and therefore it behaves like a neutral compound in the aqueous medium. Then esterification. So esterification reaction also is a reaction that is formed given by the cleavage of O and H. Okay, so alcohols when they react with carboxylic acid in the presence of the acid H plus, the reaction is reversible and it forms ester plus water. Okay, so basically in this the water is given out and water H comes from alcohol, OH comes from the acid. So water is formed and along with that ester is formed. Clear? So same reaction when alcohol reacts with the another derivative of acid, that is acetic anhydride, then what happens? ROH, then H is given out. This H combines with RCO, okay, and ester is formed. Along with that carboxylic acid is formed. Clear? So this is also reversible reaction, takes place in the presence of concentrated sulfuric acid. Okay. So when alcohol reacts with acid chloride, then if the reaction is done in the presence of pyridine, then it is not reversible, but it shows the forward reaction. That means more ester can be generated by this reaction along with HCl. So ester plus HCl is formed. This HCl combines with pyridine to form pyridinium hydrochloride. Therefore, the forward reaction is favored and more yield of ester is obtained by this reaction. Okay. Then aspirin. Aspirin is a generous medicine. Is an acetyl derivative of salicylic acid formed by acetylation of acetic anhydride. So when salicylic acid is reacted with acetic anhydride in the presence of concentrated sulfuric acid or the acid, then what happens? The OH H gets replaced by COCH3. So here you see COCH3 combines with OH and water is in this case acetic acid is given out, okay, and the acetyl salicylic acid is formed. This acetyl salicylic acid is aspirin, and it is actually the medicine to relieve pain. Okay, so it's a painkiller. So aspirin is prepared by this method. So salicylic acid, when reacted with acetic anhydride in the presence of the acid, acetyl salicylic acid is formed along with the acetic acid. Then reaction due to the breaking of CO bond. Okay, so in this reaction with hydrogen halide, so alcohols react with hydrogen halide to form alkyl halide plus water is given out. In this alcohol, if we take alcohol and react it with HCl in the presence of anhydrous zinc chloride, RCl and H2O is formed. So from alcohol you get alkyl chloride if you react it with zinc chloride and HCl. And if you react alcohol with HBr, HBr is produced in situ by the reaction of sodium bromide and concentrated sulfuric acid and heat, you get alkyl bromide plus water. Then if alcohol is reacted with HI, HI is formed with the reaction of NaI and H3PO4, that means phosphoric acid, and you get alkyl iodide plus water. Okay, so this is the reaction with hydrogen halide. So alcohols react with hydrogen halide to give alkyl halide plus water. Here. Now, distinguishing test for alcohols, Lucas test. That means this anhydrous zinc chloride and concentrated HCl, their mixture is Lucas reagent. When it is added to alcohol, alkyl chloride is obtained. So this test is actually the distinguishing test between primary, secondary and tertiary alcohol. When in the three test tubes, if you take primary, secondary and tertiary alcohol and add this Lucas reagent, then in the tertiary alcohol the turbidity appears immediately. Okay, so tertiary alcohol you get 2-methyl 2-butanol. Okay, then when you add this to the secondary alcohol, the turbidity appears in 3 to 5 minutes. Okay, and the turbidities of the secondary alcohol is being converted to the alkyl chloride, and then primary alcohol, the solution remains colorless unless it is heated. So after heating you get the turbidity. Okay, so this test helps you to distinguish between primary, secondary and tertiary alcohol. In tertiary alcohol the turbidity appears immediately. Secondary alcohol, the turbidity takes 5 minutes to appear, 3 to 5 minutes, while primary alcohol it appears only on heating. So basically in all these reactions what is happening, the group is getting replaced with Cl. So if it is primary alcohol, you get respective alkyl chloride. So if it is ethanol, you get ethyl chloride. If it is isopropyl alcohol, you get isopropyl chloride. If it is tertiary butyl alcohol, you get tertiary butyl chloride. Basically, the OH is getting replaced with Cl. So this test is Lucas test, and the reagent is Lucas reagent, constant mixture of concentrated HCl and anhydrous zinc chloride. Then reaction with phosphorus halide. So alcohols react with phosphorus halide, trihalide and pentahalide. So alcohol react with phosphorus trihalide to form alkyl halide and phosphoric acid. Okay. So if I take methanol and react it with PCl3, it forms methyl chloride plus phosphoric acid. if ethyl alcohol is taken and reacted with PbR3. How is PbR3 prepared? It is prepared in C2. The red phosphorus and bromine, they react to form PbR3 and you get bromoethane plus phosphoric acid. Clear? Then now if it is reacted with PCl5. Okay. So if alcohol is reacted with PCl5, then what happens? You get alkyl chloride plus HCl plus PoCl3. Phosphoryl trichloride. Yeah. Then dehydration of alcohols to form alkenes. Alcohols when treated with concentrated sulfuric acid. The elimination of water takes place and the saturated alkene is formed. So this reaction is called the dehydration of alcohols. So in this, if alpha carbon is holding OH and beta carbon has H, so the H and OH from the alternate carbon is removed, water is removed, given out, and alkene is formed. Okay. So ease of dehydration of alcohol is 3 degree, then 2 degree, then 1 degree. That means the most reactive alcohol towards this reaction is the 3 degree alcohol, then is the 2 degree alcohol, and finally the 1 degree alcohol. This dehydration takes place in the presence of concentrated sulfuric acid, phosphoric acid, or alumina. So here you see in detail basically what is happening. This requires acid catalyst and the reaction proceeds via carbonium ion. So acidic catalyst converts OH group into a good leaving group. Okay, OH group is a good leaving group. It leaves, and since the rate determining step is the formation of carbocation, the ease of hydration is tertiary, then secondary, then primary. So most reactive is tertiary, then is secondary, and then is primary, because tertiary alcohol forms a more stable carbocation. Okay, so the reactivity is basically dependent on the carbocation, the stability of the carbocation. So in this you see alcohol in the presence of acid and heat gets converted to alkene. Clear? So when you take the alcohol C2H5OH reacted with concentrated sulfuric acid at a high temperature of 443 Kelvin, you get ethene plus water. Clear? Now if you take isopropyl alcohol, the secondary alcohol, then the reaction happens at 440 Kelvin and 85% phosphoric acid is required for that, and the respective alkene, that is propene, is formed plus water. Okay. Now if we take tertiary butyl alcohol, and then the reaction happens in the presence of 20% phosphoric acid at 358 Kelvin, and the isobutylene is formed along with water. Yeah. Okay, now if I take this one, this is what butanol. 1, 2, 3, 4. Butanol. Butanol reacts at 75% with 75% sulfuric acid and at 413 Kelvin, and it forms but1ene as the main product. Clear? Now instead if I take now here 1, 2, 3, 4. So if I take secondary butyl alcohol and react it, then the reaction happens at 373 Kelvin with 60% sulfuric acid, and but2ene is formed as a major product. Clear? Now if I take 2-methyl propane 2-ol, there is 1, 2, 3, 4. Okay? This is iso 2-methyl propane 2-ol, then this reaction happens with the 20% sulfuric acid, and you get at 363 Kelvin and 2-methyl propionine is formed. This isobutylene is formed. Here, so this is actually tertiary butyl alcohol. It gives you 2-methyl propionine, that is isobutylene. Reaction happens at 20% sulfuric acid and 363 Kelvin. Okay, now let's see the mechanism of the reaction. Mechanism involves 3 steps. First step is the formation of protonated alcohol. Second is the formation of carbocation. And third is the formation of ethene by the elimination of a proton. So basically in the formation of protonated alcohol, what happens? This reaction is happening in the presence of acid. Acid provides H plus ions. So the proton gets added on the alcohol and you get protonated alcohol. This reaction is a reversible reaction and it is a fast step. Clear? So this lone there are lone pairs on oxygen, and H plus is short of electron. So H plus attacks on the oxygen and takes the lone pair. So oxygen gets positive charge and oxonium ion is formed. Okay. So then this second step is what? This oxonium ion slowly this oxygen is carrying a plus charge. So plus charge is balanced by the cleavage of the CO bond, and water is given out and carbon gets a plus charge. So that means ethyl carbocation is formed along with giving out water. This step is a slow step and of course a reversible step, and this is the rate determining step. Clear? So then in third step what happens? The carbon is having plus charge. The plus charge is carbon is given out by breaking cleavage of the CH bond. Proton is given out and ethene is formed. So this is formation of ethene by the elimination of proton. So basically in the mechanism there are three steps: formation of protonated alcohol, formation of carbocation, and formation of ethene. Clear? So in dehydration reaction, the highly substituted alkene is a major product, and if the major product is capable of showing cis-trans isomerism, then trans product is the major product. This is Sedzev rule. Okay. So in the reaction, butane 2-ol undergoes dehydration to give you but2-ene and but1-ene, out of which but2-ene is a major product and but1-ene is a minor product. So in this, what is happening? The two carbons, there's a two beta carbons. So this alpha carbon is having OH. Okay. So if more substituted alkene is the priority, and therefore the OH is given out by the alpha carbon. Now beta carbon, which beta carbon should release H? So if this beta carbon, the first beta carbon releases H, then in that case the product is but1-ene. But if the second this releases H, then the product is but2-ene. So but2-ene is a more stable product according to the Satzev's rule. Clear? Then oxidation of alcohols. Oxidation reaction for alcohol is happens with the oxidizing agent, and these oxidizing agents are CrO3, PCC. PCC is pyridinium chlorochromate. Okay, so if it is secondary alcohol, it will always oxidize to ketone, whatever may be the oxidizing agent. But if it is primary alcohol, it will oxidize to acid, or it may oxidize to directly to the aldehyde, or it may oxidize directly to the acids. So this depends on which oxidizing agent we are using. So if you are using PCC, that is a pyridinium chlorochromate. So if you are using this oxidizing agent, then aldehyde is formed. It is restricted oxidation. But if you are using the strong oxidizing agents like KMnO4 and acid, or alkali, K2CR2O7 and acid, or HNO3, then what happens? Primary alcohol first oxidizes to aldehyde and then it further oxidizes to carboxylic acid. So the final product is carboxylic acid if we are using these oxidizing agents. But if we are using the oxidizing agent as PCC, that is pyridinium chlorochromate, then the oxidation takes place till aldehyde. That means primary alcohol gets oxidized to aldehyde and not acid. Okay. Tertiary alcohols normally do not undergo oxidation, or they undergo oxidation under drastic conditions. Okay. So let's see here the oxidation of primary alcohol. If I take ethyl alcohol, it oxidizes to acetaldehyde and then further oxidizes to acetic acid in the presence of KMnO4 and H+. Then if we take isopropyl alcohol, this oxidizes first to acetone and then this further oxidizes to acetic acid, carbon dioxide and water. So the final product here is acetic acid, and the isopropyl alcohol had 3 carbons, but the final product is having 2 carbons. So the final product acid is having 1 carbon atom less than the uh, initial secondary alcohol. But if I take tertiary alcohol and oxidize it, It forms acetone, carbon dioxide and water. And then in the second step, it is forming acetic acid, carbon dioxide and water. So here in this case, the final product is having 2 carbon atoms less than the primary reactant. Clear? So when common oxidizing agents like nitric acid, potassium permanganate, manganate or potassium chromate are used to oxidize primary alcohol, the oxidation does not stop at aldehyde stage, but aldehyde formed further gets oxidized to carboxylic acid containing the same number of carbon atoms. Okay, but if you are oxidizing the secondary alcohol under the similar condition, you get the final product as a carboxylic acid having 1 carbon atom less than the original alcohol taken. Then tertiary alcohols are difficult to oxidize. On their oxidation, strong oxidizing agents are needed, high temperature is needed, and finally tertiary alcohol oxidizes by the breaking of carbon-carbon bond, and it gives a mixture of carboxylic acid having a carbon atom, 2 carbon atom less than the parent alcohol. Clear? Then for oxidation of alcohol to aldehyde, PCC is required, that is pyridinium chlorochromate. Clear? Then another way to do the oxidation is heating with copper. Basically in this what happens, the alcohols are passed over hot copper and the reaction takes place. So 1 degree alcohol gets oxidized to aldehyde, 2 degree alcohol gets oxidized to ketone and 3 degree alcohol gets oxidized to alkene. So in this basically what happens with copper, dehydrogenation takes place. So copper 573 Kelvin oxidation takes place and in the form of dehydrogenation. That means hydrogen is given out in these reactions. Clear? Then alcohols, methyl alcohol is used, uses of alcohol. Methyl alcohol is used as a solvent for paints and varnishes. Ethyl alcohol is used as an antifreeze agent in automatic radiators and it is also used as a solvent. Okay, clear? Thank you.